right, guys, we're going to look at some more complex calculations and kind of work through a few of these together. So as with every other calculation, you always want to make sure that you know what we're looking for. Focus in on what the question is actually asking. There's going to be a lot of information and you kind of need to narrow it down. For problems like this, the really complex ones, I highly recommend dimensional analysis. It keeps everything in one place. It prevents you from missing steps. Now, some of these problems may have multiple parts, so plan ahead. Think about what different steps do I need to take, and we're going to look at an example of that. Whatever it is, take your time. Don't rush. Make sure that you're being safe in this calculation and getting the right answer at the end of it. Always triple check. Plug your answer back in. Does it make sense? All right, let's work through a couple of these together. So example number 1, the order is for dopamine 7.5 micrograms per kilogram per minute IV infusion. What we have available is dopamine 800 milligrams in 250 milliliters of D5W. The patient weighs 207 pounds. How should you set the IV pump? Well, IV pump is always what? Milliliters per hour. So dimensional analysis. Start with what you are looking for, milliliters per hour. Transfer your units over, milliliters. What do we know? What are we given about milliliters? Right here, we know that for every 250 milliliters, there are 800 milligrams of dopamine. Okay, transfer our units up. What do we know about milligrams? Well, we don't have anything else, do we? We've already used this one, so we're going to have to do a conversion. 1 milligram is 1,000 micrograms. Okay, transfer your units up. Remember, these can cancel. Now, what do we know about micrograms? Well, we know that we have 7.5 micrograms per kilo per minute. Anytime you have a double per, put them both on the bottom. All right, cancel micrograms. Do we have what we need yet? Well, we've got milliliters because we started there. We need to get to hours. Well, we've got minutes, so let's do that conversion. 60 minutes in 1 hour. So we can cancel minutes, we have hours, we have milliliters per hour, but we still have this kilograms just hanging out on the bottom. Remember, your goal with dimensional analysis is to cancel everything until you're left with only what you need. So we've got to get rid of this kilograms. Let's transfer those units to the top and let's do a conversion. 1 kilogram, 2.2 pounds. Cancel kilograms. What do we know about pounds? We know the patient weighs 207 pounds. Cancel, cancel. Now we've canceled everything. We're left with just milliliters per hour. We know we can move forward. You're going to multiply across the top, divide across the bottom. 250 times 1 times 7.5 times 60 times 1 times 207 divided by 800 divided by 1,000 divided by 1, these are your hypothetical ones, divided by 1, divided by 2.2. The number that you end up with in your calculator should be 13.231, etc. Round to the nearest tenths, because this is milliliters per hour, you're going to end up with 13.2 milliliters per hour. Do your final verify. Does it make sense? You can always plug it back in, but 13.2 seems like a reasonable number, so we know this is correct. All right, let's look at another one. Heparin, 12 units per kilo per hour IV infusion. What we have available, 20,000 units of heparin in 500 milliliters of normal saline. The patient weighs 184 pounds. How should you set the IV pump? Again, milliliters per hour. Always know what you're looking for. So with dimensional analysis, we start with what we're looking for, milliliters per hour. We transfer our units over. Insert what we know, convert if we don't. What do we know about milliliters? For every 500 milliliters, there's 20,000 units. 500, 20,000 units of heparin. All right, transfer your units up. What else do we know about units? Well, right here, we know that we want 12 units per kilo per hour, okay? Again, if you have two pers, put them both on the bottom. Kilo per hour. All right. So we cancel units. We've got our milliliters, we've got our hours, but again, we've got this random kilos just hanging out down here that we've got to get rid of. Okay, so do we know anything about kilos? Nope, but we can convert. 1 kilogram is 2.2 pounds. Cancel kilos, bring the pounds up. What do we know? Patient's 184 pounds, cancel, cancel. So again, with dimensional analysis, the goal here is to cancel everything till we end up with only what we want. We've canceled everything except milliliters per hour, so we know we're good to solve. You're going to enter this into your calculator, multiplying across the top, dividing across the bottom. 500 times 12 times 1 times 184 divided by 20,000 divided by 1 divided by 2.2. What you're going to end up with is 25.0909 milliliters per hour. Round to the nearest tenths place, and your answer is 25.1 milliliters per hour. You've rounded, you've got the right units. Does it make sense? Does it seem appropriate? Yes, it does. All right. Let's do one more. Now, this is a problem that we find in nursing school that honestly are some of the hardest ones in my opinion. This is going to require multiple parts because not only do you have to figure out what's currently going on, but you have to interpret an order, implement it, and then find the new rate. So let me read you the question. A patient has heparin infusing at 22.1 milliliters per hour. The bag contains 20,000 units of heparin and 500 milliliters of normal saline. The patient weighs 162 pounds. The patient's PTT returned at 42 seconds when we tested it. Based on the orders below, what should the new IV pump rate be? So what we're having to do is determine where we're at, determine where we need to go based on the order and this lab result, and then determine the new rate. So there's actually going to be 3 steps. One is, what is it currently running at? What is the current dose? Now, the reason we need the current dose is because this order is based on units per kilo per hour, not based on milliliters per hour. So again, this is where you have to take your time, look closely. What does it give you? What do you need? What units are you working with? So the first thing we need to do is determine the current dose in units per kilo per hour. Second thing is we're going to use our orders to determine what the new dose needs to be. Where are we going with it? You can see if it's less than 30 seconds, we're going to increase by 2 units per kilo per hour. If it was between these, we were going to decrease by 2 units per kilo per hour. So the order tells you what you need to do. And the third step is then going to be, now that we know the new dose, find out the new rate. So we've planned ahead. We know what our 3 little steps are. So let's go ahead and do them. So part 1 is, what is the current dose? So patient has heparin infusing at 22.1 milliliters per hour. The bag contains 20,000 units of heparin and 500 milliliters of NS. The patient weighs 162 pounds. The information about the PTT and the new dose, we don't need that yet. We're starting with part 1. What is the current dose in units per kilo per hour? So start with what you're looking for. Units per, double per, kilo per hour. Transfer your top units across. What do we know about units? 20,000. So 20,000 units is in 500 milliliters. Transfer your units across. What do we know about milliliters? 22.1 milliliters in 1 hour. Cancel milliliters. We've got units, we've got hours, we're missing kilograms. So let's say 1 kilogram down here because that's where we need it, right? And then we're going to do a conversion because we don't know anything about kilograms. So 1 kilogram is 2.2 pounds and the patient weighs 162 pounds. Cancel pounds. Now we've got what we need. Units per kilogram per hour. When you do this math, you are going to end up with 12.00493 units per kilo per hour. Now, I happen to know from doing the math that if you were to round this to 12, you'd get the same final answer. But for the sake of safety, we're actually going to use this number as we move forward, and we'll kind of go from there. So part 2 is now to determine what does our new dose need to be. We've already determined that our current dose is 12.00493 units per kg per hour. So we know this information. Now we know that the patient's PTT returned at 42 seconds. Based on the orders below, what should the new dose be in units per kilo per hour? So 42 seconds falls right in here between 31 and 54. So we need to increase the rate by 1 unit per kg per hour. So now the new dose, instead of 12.00493, is going to be 13.00493 units per kg per hour. That's it. That's your second step. This is where we're headed. So let's go to part 3. Let's remember our new dose needs to be 13.00493 units per kg per hour. So same information. Based on the new dose you decided, what should the new IV pump rate be? IV pump rate is always milliliters per hour. So start with what you're looking for. Milliliters per hour. Transfer your units over. Milliliters. What do we know? Well, we know a couple of things. Since we know we're looking for a new rate, putting in the current rate's not really going to help us, is it? So let's start over here. We know that 500 milliliters is 20,000 units. Okay. What else do we know about units? Well, didn't we just figure out what new units we want? Yep. So 13.00493 units, double per kg per hour. Okay. Cancel units. We have our milliliters, we have our hours, we have the kg hanging out. So do we know anything about kg? Nope, but we can convert. 1 kg, 2.2 pounds. Cancel your kgs. Now we need to cancel our pounds. The patient weighs 162 pounds. All right, we've canceled kgs, canceled pounds, canceled units. We're left with milliliters per hour. If you put this directly into your calculator, multiply across the top, divide across the bottom. 500 times 13.00493 times 162 divided by 20,000 divided by 1 divided by 2.2. The answer that you are going to get is 23.94089. Okay? Round to the nearest tenth, you're going to get 23.9 milliliters per hour. Now, if you had rounded this and used just 13 as opposed to 13.00493, you would have ended up with 23.9318. Again, rounding to the nearest tenths, you still would have ended up with 23.9. However, you can see how those simple things, if this had ended up, 9.5 something something, and this had ended up 9.4, this one would have rounded up and this one would have rounded down. So that is why we always say to round at the end, if at all possible. Okay, so there's your answer, 23.9 milliliters per hour. So part of the issue with this type of problem, let's go back to the whole one. With these multiple parts is there's a lot of information here, right? And so by planning ahead, by determining what information you need at each step, you can kind of start to pick and choose which information is the most important, keep yourself from being distracted by things that aren't important yet. So I hope that made sense to you. I know that it's a complex problem. Please feel free to repeat this video again, watch this multiple times, use some of the example problems that we've given you, and try your luck. Practice, practice, practice. The more you do these, the more sense they're going to make to you. I hope that was helpful, guys. We love you. We just want to see you be successful. Now go out and be your best selves today, guys. And as always, happy nursing.